My name is Rajiv Mahajan, and I'm a customer engineer in Google's retail practice. Today, we are going to be talking about migrating on-premises Hadoop infrastructure to Google Cloud Platform. Let me introduce my co-presenter up here.
I'm James Malone. I'm a product manager with Google Cloud Platform. I PM a couple of products. One of them is Cloud Dataproc. Unfortunately for you guys, we've hidden all of our secret new features in the side of the slide deck here. So we have a few other presentations today where we will be announcing all of our secret stuff. So you just have to kind of wonder what's under the mysterious black box there. With that, I'm going to go ahead and turn it over to Rajiv.
Thanks. So whenever you think about migrating from on-premises clusters to Google Cloud Platform, there are three aspects that you have to consider: migrating your infrastructure, your data, and your jobs. And that's what we are going to talk about today. Okay? There are a few recommendations we are going to make, and we are going to stress them over and over again in this presentation. And they are as follows. First, when you're thinking about infrastructure, we highly encourage you to look at other Google Cloud Platform services that will really make running your clusters very economical and very efficient. Second, we want you to consider migrating from HDFS to Google Cloud Storage. And we'll talk about why and how. Third, we want to again encourage you to consider something called ephemeral clusters. Ephemeral clusters are job-specific clusters, as contrasted to general purpose clusters that run multiple jobs in a shared cluster environment. So we want to encourage you to think about those, and we are again going to talk a lot about them. So that's the general outline of this presentation. Let's get the most important things out of the way very, very quickly. What are the benefits of migrating to Google Cloud Platform? And consider the fact that I'm saying Google Cloud Platform. I am not saying Google Cloud Dataproc. There is a reason for that. So let's see what that means. First, Google Cloud Dataproc, which is what you will be migrating to, is a cloud service. So you get pay-as-you-go, and you get vast and varied scale. Make sense? Second, it is a managed service. We provision the VMs for you. We provision the clusters for you. We deploy operating systems on them, and we deploy the open source stack on these nodes, which means that you don't have to do it, and you don't have to carry the administrative overhead to do it. Third, if you think about Cloud Dataproc, that is Google's implementation of the open source Hadoop infrastructure. Let me define Cloud Dataproc as we talk about it internally. Cloud Dataproc is a service, managed service, to run your Spark and Hadoop jobs. That's what it is. If you're trying to migrate from your on-premise clusters, which are running that open source stack, it's very easy to do that by just making some minor modifications to your job code. If that's all you are looking to do, you are focused on a lift and shift strategy right now, it's very simple to do that. But I think where you get value is when you start implementing our recommendations that we've just talked about, and I am going to kind of elaborate on what that value proposition is. Okay? The next two, 4 and 5, really are about Google Cloud Platform. They're not about Google Cloud Dataproc. We just talked about running ephemeral clusters, which are job-specific clusters. And what we are trying to stress there is, rather than deploying a whole bunch of libraries for running Hadoop and Spark and Hive and whatever else that you can think of, we just want you to focus on the job of interest. That means you do not have library clashes, et cetera, et cetera. The management overhead is low, and it really greases the wheels of your operations really, really well. Make sense? Finally, Hadoop has a blind spot. And the blind spot is when you are working with persistent data, it is in HDFS. And it is not very easy to go and unlock the value of that data and move it to other platforms where the value really gets used. Let me establish a very simple use case. Say you just ran a Spark job. And the Spark job was creating recommendations for powering your personalization engine on your website. How do you get that data that your Spark job just generated, which is stored in HDFS, out to your recommendation engine? That is a challenge. And we, with our whole plethora of different services, actually do that really well. And we are going to talk about this a couple of different points, OK? Let's get started. Section number 1, we're going to focus on infrastructure. Let's step back. Let's look at our on-premise clusters. There are 3 characteristics which stand out for these on-premise clusters. 1, they're monolithic, and they have large number of nodes that you need to make sure get upgraded and have the right software in tandem. If you don't do that, you have trouble, and you know all that. Second, these are persistent. They run for many days, which means it leads to other kind of management overhead with making sure that everything, all the job configuration is right, and there are no clashes, and nothing has died, and everything is up. Third, these clusters are shared across jobs, teams, projects, and that sharing infrastructure leads to a whole bunch of different problems that you are probably very aware of. I'm not going to focus on that. We're going to talk about how to solve these problems. The key characteristic which creates a lot of problems with on-premise clusters is the fact that they are persistent and they're shared. And we just talked about data being locked in HDFS, and we need to figure out a way to unlock that. So that's one limitation. Second, HDFS, because of its replication factor, 2, 3, 4, I don't know what you guys are running with, it's expensive. Third, if you are not using Google Cloud Platform, you have an opportunity cost. What is that opportunity cost? You cannot use other services that can help unlock the value inside your clusters. Make sense? Let's look at some solutions now. Very simple diagram, first of many. Your on-premise cluster is on the left, and your migrated clusters are on the right. On-premise, you are running 2 clusters, 4 jobs, and 2 HDFS setups. When you're done migrating, you are actually have 3 clusters. Job 3 and 4 actually get their own clusters. Remember, I've been talking about ephemeral clusters, which are job-specific, which means 1 cluster per job. So I got 3 clusters running, and all my data is stored in Google Cloud Storage buckets. So remember, I said migrate from HDFS to GCS, use ephemeral clusters. This is that architecture. Very simple, basic. We're going to build on this. But this is our starting point. Now, before we actually delve even deeper, let's talk about 2 very important architectural principles that are embedded in Google Cloud Dataproc. And our migration recommendations align really, really well with those architectural principles. The first architectural principle is separate your data from computation. Now, this particular architectural principle is not unique to Cloud Dataproc. Pretty much all of Google's big data platform and different offerings, BigQuery, et cetera, they are built on this architectural principle. Now, how that translates into specific things you need to do with Cloud Dataproc are follows. First, we're asking you to migrate from HDFS to GCS. That's your separation. Separate the data out from the cluster. Remove it from HDFS. GCS is HDFS compliant, which means there is only slight modifications you need to make to your code, and we will actually show you what those are, and you are running in Cloud Dataproc. But as I said earlier, if all you're looking to do is to do a lift and shift, it's a very simple thing, but if you're trying to get value, we will go and talk about other things. Second, GCS is faster. GCS is definitely more economical. And GCS is very easy to manage. Little to no management overhead. And we already talked about the fact that if you are looking to unlock value from within HDFS, and if you move to GCS, the way it works is most of Google platform technologies work very seamlessly with Google Cloud Storage, which means that is your venue, that is your door to opening the value from within cloud, from your on-premise clusters in Cloud Dataproc. Make sense? Let's talk about the second architectural principle, which I've already talked about 3 times, and I'm going to talk about 10 times more. Use ephemeral clusters. Now, if you have jobs sharing the same infrastructure, you have to do a setup before every job run. You have to make sure that the configuration for the cluster for that particular job run is set up right. That's quite a bit of management overhead. If I actually am now running clusters which are job specific, I don't have to do that. I just have to configure that particular job. I also don't have to deploy a whole bunch of different libraries. So if I'm running a Spark job, I don't need to deploy Hadoop libraries or Hive libraries. Make sense? Easier to manage. The easiest analogy I can think about this architectural principle is that old proverb that you've heard. Fire is a very poor master, but a great slave, or some variation of that. Clusters, because of all the limitations we talked about earlier, are actually running you ragged in most cases. We are trying to relieve that pressure by taking control back over our clusters through the ephemeral cluster design. Make sense? It's logical, right? Now, what do you get with this? One that you get, first thing you get is the ability to have very controlled configurations, much finer control over your jobs. Second is I can actually scale my cluster independently of any other job that I might be sharing in a shared cluster architecture. So I could deploy 1,000 nodes for one job, whereas my cluster itself was 100 nodes earlier. Huge value unlocking. Let's keep going. Job-specific cluster, how does it work? I start my job through Cloud Dataproc, API or through the UI, doesn't matter. It spins up a cluster for you, which you configured earlier. The job runs, it generates data. In this case, I'm actually outputting data to Google BigQuery, Cloud BigQuery. And we'll talk about why that is so. I also am storing data in cloud storage. I run my job, and once the job is complete, I actually delete the cluster. I delete the cluster. Can you believe it? Because this is a problem. We talked about this diagram earlier. That was our simple starting point. Life is never simple. Simple diagrams don't actually do justice to the problems we have to face in the real world. Let's build on this a little bit. This is my migration end state, the cloud native solution. On the left, in green, you see my ephemeral clusters. We just talked about them. Job specific. I can have a bunch of them. I don't need 1, 2, 3. I could have hundreds of them if need be, as required. In the middle, in blue, you see my different data stores. I already talked about cloud storage. I'm adding two more to this mix. It's BigQuery and Bigtable. BigQuery, for those of you who do not know about it, is a petabyte scale data warehouse. And Bigtable is really about managing sparse data that you want to read and write to very, very fast, very low latency read and write access. Both of those are now available for me. Remember, I was talking about unlocking that value stored in HDFS. That's what we are doing. We also are talking about monitoring and logging. Get a little bit better idea of your operations and what you need to tune as you actually get data from runtime. Below my ephemeral clusters, you see an orchestration engine. You see Apache Airflow. Apache Airflow or a variant like an Azkaban, that's what you can implement for coordinating the flow of your jobs and their dependencies. We actually have recently GA'd a product called Google Cloud Composer. And James has a very, very big session in the afternoon today. You want to give some details about that session?
Yeah, so there's a session at 1:55 on our GA launch of Cloud Composer, which is a managed Apache Airflow service. And the goal with having a managed Apache Airflow service is to solve the cloud level workflows and orchestrations, but have a product that's open source that can talk to things inside of Google, talk to things outside of Google. In that session, we'll be talking about why we launched Composer, kind of our vision for Composer. If you're new to Airflow, we'll be breaking apart an Airflow DAG and giving a demo of Composer. So it's a good kind of baseline and intro to Airflow and Cloud Composer if you're curious. And it's at 1:55 today. And I think it's not quite full, but it is almost at capacity. So if you're curious, do sign up for it.
OK. And now, in yellow on the right, yellow or orange, whatever you're seeing, I have persistent clusters. What? Did I just tell you that you need to go with ephemeral clusters, stateless? And I'm telling you, you need to have persistent clusters in this architecture? Life is complex. We'll talk about it in a couple of seconds. Say you have a Spark streaming job. Running it on an ephemeral cluster is next to impossible. You need a persistent cluster. You may also have a use case where you have a bunch of different jobs that need to run together. They're dependent on each other. And some of these jobs actually are very short run. They might just be ingesting data into the cluster itself or into GCS from a source. The overhead of spinning up a cluster might be much larger than you want to tolerate. That's also a good case for running maybe a short-run persistent cluster, but a persistent cluster nonetheless. Make sense? But if you are going to run a persistent cluster, here are a couple of recommendations. Number one, scope it to be the smallest possible cluster that you can think of in terms of number of jobs you're going to run and the number of nodes that are going to be part of that cluster. It's a very, very simple recommendation. So we talked about the underlying components. We talked about architectural principles. Let's get to the mechanics. First, move data to GCS. Again, I'm repeating it again. Do it incrementally, and we'll actually talk about a couple of strategies in a couple of minutes. Second thing is experiment. What does that mean? Now that I have actually opened up the architecture for you, I can run job-specific ephemeral clusters. I want you to run proofs of concept. I want you to experiment with the size of your cluster, the number of nodes, try out different configurations, figure out what works best for you in terms of the dollars that you're spending, the time it takes to run a particular job, because that's a requirement in many cases. I want to go from 12 hours to 2 hours. That's my new window. You can experiment, and you can actually make it happen with Cloud Dataproc. So that's our recommendation. Central to all of this is ephemeral clusters, which we have been talking about over and over again. Migrating incrementally. OK, so what's new? Anybody who has been in the world of IT thinks in terms of eating the elephant in small chunks, right? The only guidance up here is when you are actually creating POCs or you're defining the scope of your agile sprint, if that's your thing, then think in terms of dependencies of the jobs, move them together. It will actually make things simple for you. Remember, what ephemeral clusters are stateless. You have input, you have output. There's nothing inside the cluster itself. It runs, it dies. It rises up like the phoenix, and it dies again. It's the cycle of birth and rebirth keeps on going on with an ephemeral cluster, right? Think incrementally. Let's take actually a look at an architecture which will help you do that. This architecture is something called a backfill pipeline. Are you guys aware of this? Have you ever heard of this? Anybody? Yes? OK. So say you have your big data stack running for the last 3 years. Recently, in the last 6 months or so, you created a bunch of new jobs. But since your cluster is already running to capacity, you never had the time to go back and run these jobs against your archive data from 2.5 years ago. The idea of a backfill pipeline is to actually take your jobs and run it against archive data. So how is that relevant to us? Remember, I've been saying experiment. Using your jobs, the newly migrated jobs, against archive data is actually a very good way of validating that your jobs will run well, they will run correct, and you will get the characteristics you are looking for in terms of performance, times, et cetera, et cetera. Make sense? So this is one low-risk architecture. The key component up here is that little box in the middle, which says Internet Gateway and Cloud Storage. We are trying to bring data over from your on-premise cluster into Cloud Dataproc. That's the key idea there. And we're actually going to expand on this a little bit further. OK? So you are in the middle of a migration. Before migration, you had your on-premise cluster. After migration, you have that cloud-native architecture I talked about. Somewhere in the middle, both of them are living together. That's the idea behind hybrid architecture. Nothing new there. Now, this hybrid architecture we just talked about is being imposed on you by the requirements of being in the middle of a migration cycle. But there might be business requirements for you to actually have a hybrid architecture. I'll give you an example. One of my customers is actually running their order management system on-premise. They're looking to migrate it to the cloud. But the problem is, it's going to take a little bit of time for them to figure out what that looks like. It's a monolithic system. They need to figure out how to create microservices, et cetera, and do that appropriate migration. So they want to, for the foreseeable future, run their extraction and big data jobs relating to order management system in-house. That's the hybrid architecture we are talking about. Example, again, ephemeral clusters in green on the left. We have the storage in blue, and we have on-premise yellow on the right. And in the middle is a contraption for bringing your data over from your on-premise clusters over into cloud storage. VPN gateways are involved, and some more clusters are involved. Now, these clusters are for actually copying the data over from your on-premise cluster over to cloud storage. There are a couple of mechanisms there. It's really out of scope of this particular presentation, but we will point you to a couple of links where you can actually go and take a closer look at them. And maybe this is something where you actually engage Google professional services to help you with. Okay? There's a push and pull kind of an architecture involved. Of the 3 recommendations I gave you in the beginning, the first one was look at a broader portfolio of Google Cloud services. Let's talk about what are the considerations there. Regions. Say you are deploying your architecture. It's a multi-regional architecture. And for some reason, your persistent data in Google Cloud Storage is sitting in a region which is separate from where your resources are located. Your ephemeral clusters are located, etc. What is probably going to happen for you is Google Cloud is probably going to, in certain cases, copy the data over from one region to another. There are latency considerations, and there are cost considerations because of egress costs. And you need to think through some of that, especially if you are building any kind of DR kind of a setup. Okay? All Google Cloud services have Stackdriver logging and monitoring built into them. You can use your on-premise or whatever tool you are using to bring that data, or you can actually use Stackdriver. We think it's pretty cool, so you should stay with Stackdriver, but it's your choice. Finally, I have talked about this multiple times. We can store data in BigQuery and in Bigtable as needed. Section 2. So we've talked about infrastructure. Let's talk very quickly about data. We've been through this a few times. You can migrate data from Apache HBase to Bigtable, equivalent technologies. You can migrate data from Apache Impala to BigQuery. And if you've got Hive running, you may want to think about running your Hive metastore on Cloud SQL, which is Google's open source implementation of MySQL. Make sense? Security. You are never going to get the level of granular control that you get in HDFS. But using Google's IAM policies, you can have equivalent control over the data that is stored in Google Cloud Storage. We are recommending that you apply controls at the level of buckets, not at the level of files. But if, for some reason, your use case requires that you work at the level of a file, then think in terms of using GCS ACLs. We don't recommend it, but if you have to go down that path, you have to go down that path. Make sense? Speed. I process terabytes of data per day, and my VPN connection is not fast enough or doesn't have enough bandwidth. What do I do? So some people deploy multiple VPN connections. That might solve the problem for you, depending on the data that the volume of data you're working with. Or you may want to look at two alternative technologies to plug into Google's network. Direct peering. Have you guys been familiar with direct peering? Anybody deployed? Direct peering is essentially your ability to tap into Google's fast network directly through the point of presence, what do we call them? POPs? POP network setups. If you are unable to do that for any reason, you can actually use our partner services called Cloud Interconnect services, where a partner actually lays the cable from their data center, which is kind of co-located and connects into Google network, and you can broaden that bandwidth. Make sense? So these are the key elements for data. It's bandwidth, it's access control, and where you're storing data. Let's talk about jobs. Remember, the first thing I said was if all you're looking to do is to migrate your jobs from on-premise to Cloud Dataproc, it's very, very simple to do. HDFS, those 4 letters, you replace it with those 2 letters, GS. That's all you need to do. It's pretty cool, huh? We support, these come as default setups, but we are not limited to actually supporting these. So we have something called initialization actions, where you can define what kind of stack you want to run, and it will, at runtime, deploy the stack for you, and you can continue with your running that particular stack or jobs. So these are just the default configurations available to you. But initialization actions lets you open up the whole stack, right?
That's correct. Something that's not on here that's a feature that we are releasing in the next few weeks is the ability to also pick and choose which components you would like on your cluster. So canonically right now, when you create a cluster, you can specify one or more initialization actions. And those initialization actions are shell scripts or anything that can be executed in a Debian environment. People have asked for the ability to do things like tick a box. So I want a cluster with Spark and maybe add Zeppelin or HBase. So in the coming weeks, you'll see when you create a Dataproc cluster, there'll be additional options. And you just say create a cluster with Zeppelin, Anaconda, Livy, whatever else you want. That makes it easier to create the cluster with the optional components. It also means on the back end, we're testing all of those components against each Dataproc image build. That's probably a session in and of itself, because how we build the image is really interesting, but quite a lengthy process. But it also means that we're testing all of those components against our weekly image builds to make sure that they work, that things don't break with each new release of Debian, each new release of the open source components and all of their dependencies, which can be quite complicated. So it's abstracting away quite a bit of that complexity for you, so you don't have to worry about it.
The key point I wanted to actually bubble up in this particular slide are two things. One, as you migrate from your on-premise cluster over to ephemeral clusters, you may want to start with the smallest possible configuration that is closest to what you were running with, and then do the experiments. You might find that even with a smaller configuration, you might get equivalent performance. You'll be surprised there. The second point I wanted to make was this point about preemptible instances or preemptible workers. Preemptible workers is really a cool feature wherein you can take discounts of up to 80% on the regular pricing on instances that Google, if needed be, can reclaim back by telling you that we are actually reclaiming these instances. But if not, you can run some of your higher latency jobs, something that is not critical, at a lower price point. They're a very, very cool feature. Final piece is all about scalability. Cloud Dataproc allows you to scale both up and down. And we also have this concept of graceful degradation. So we actually let the cluster figure out that it's ready to scale up or down, usually down at the right moment without crashing nodes and creating problems for you. Last piece in this is restartable jobs. Dataproc also has the intelligence to figure out if a job has actually completed or it was aborted for a plethora of different reasons. Maybe some services were not available, or you had some dependencies that you couldn't do anything about. So you may want to think about building your jobs or modifying them slightly so they are restartable. Make sense? For longer running jobs, say a Spark job that runs for 20 hours or so, what you may want to do is use preemptible instances, but build in your own variation of checkpointing in it. So at the appropriate time, save the data into cloud storage, and if for some reason the instances get preempted and you have to restart, you still haven't lost 15 hours of work that you did. It's not complicated to do. It's very simple, and if any of you guys want to talk about it, we can do that offline. Make sense? Now you've got the migration done. We are wanting to run this on an ongoing basis. What you may want to do is to apply custom labels for identifying your clusters, cost chargebacks, et cetera, et cetera. This is just a basic feature built into all of Google Cloud Platform. We've already talked about organizing GCS buckets to separate jobs and apply access controls. And finally, we've talked about ephemeral clusters and the ability to run one or closely related jobs on the same cluster.